Hi, I'm Wenxin Zhu from Nagoya University. I'm glad to introduce our research, MSCCD, grammar pluggable clone detection based on ANTLR parser generation. Our topic starts with the diversity of programming languages. As you know, no programming language can meet all needs. Therefore, many programming languages are proposed. We collected release logs of 10 popular languages, including their minor and major versions. As you can see in the graph below, these programming languages are also updated frequently. However, the existing code clone detection tools are not extensible enough. Most code clone detection tools only support a limited range of languages like C, C++, and Java. And most tools do not provide a mechanism to support new languages. Users cannot make these tools support a new language without modifying the source program. Furthermore, none of the code clone detection tools can support both multilingual mechanisms and Type 3 level clone detection. To resolve these problems, we proposed MSCCD, a multilingual syntactic code clone detector. Unlike traditional code clone detection tools, MSCCD takes grammar definitions and source files as input. MSCCD can detect Type 3 clones in various granularities. MSCCD has three phases. First, it generates a token bag extracted by the input grammar definition files. Then, MSCCD generates token bags for the input source files. At last, MSCCD detects code clones between token bags. MSCCD uses ANTLR to generate a parser for the target language, which in turn generates a token bag extractor for the target language. Now, grammars of the most commonly used languages can be found in the Grammar Swiffer community, which makes MSCCD easier to achieve high language extensibility. A primary challenge of MSCCD is to extract code blocks for different languages. Our main idea is that each subtree in the parse tree corresponds to a code block. It does not rely on any special grammar rule, so it can be used on parse trees generated by an automatic generated parser. MSCCD simplifies the generated parse tree. By doing so, the wholly overlapped code blocks and the tiny code blocks can be filtered out. The depth of each subtree in a simplified parse tree is defined as the granularity value. A bigger granularity value presents the finer granularity. Besides, clone detection is always interested in some compositions like functions. To define these compositions, we must use keywords in grammar. So, MSCCD provides a keywords filter to only reserve these keywords-related code blocks. By using the keywords filter, the clone candidates can be reduced so that MSCCD can be executed faster. MSCCD converts the extracted code blocks into token bags, which are collections of elements with duplicates of keywords, identifiers, and literals. And then MSCCD groups these token bags by their granularity values. In other words, MSCCD only detects code clones between token bags whose granularity value is the same. We believe that the granularity value is also a part of the code block semantics, though the cloned code has a high probability of having the same granularity value as the metacode. We did some experiments to evaluate MSCCD's performance. We checked if MSCCD can generate token bags for classes, functions, condition statements, and loop statements of 20 popular languages for evaluating the language extensibility. When using the keywords filter, 90% languages in functions and 75% languages in classes can pass the keywords filter. and all languages in loop statements and condition statements can pass the keywords filter. That is because these languages use a different rule pattern to define functions and classes. When inactivating the keywords filter, MSCCD can support all compositions of all the 20 tested languages. Because MSCCD is based on the parser generated by the general tool and we didn't provide any optimization for any language, we used the existing benchmark Curriculum Bench to evaluate the general performance of MSCCD. As a result, MSCCD has an equivalent record and precision with state-of-the-art tools. When only considering the reported pairs in granularity values 0 and 4, MSCCD can be regarded as a function-level detection tool for Java. At this time, MSCCD also reported an equivalent record with the other tools. As for execution time, MSCCD can also complete detections on 100 million lines of code repositories in about 6 hours. At last, in this work, we proposed a code block extracting method based on ANTLR parser generation. And we implemented that method into a multilingual code clone detector, which can detect type 3 clones and support most of the widely used languages. In the future, we're interested in evaluating MSCCD's precision and even record in other languages. That's all. Thank you for listening.